The cognitive load theory and cognitive theories of multimedia are important theories to consider when designing instruction. The cognitive load architecture has three main components. First, working memory, second, long-term memory, and third, schema. So how these three components work together in that cognitive load architecture is that working memory is very limited. So the goal is to find a way for this new information to be stored in long-term memory, which is essentially limitless. To accomplish this goal, the new information must flow from the working memory through our schema, and then it can be stored in long-term memory. So again, very limited working memory means that it has to flow through this schema. So our schema is the funnel or the buckets of information that we already know. It's things we already know that new information is going to flow through. Schema is how we make sense of this new information based on what we already know. So let's consider a first grade student in a phonics lesson at school. Included in that student schema is that they already know that each symbol or letter of the alphabet has a specific sound associated with it, which is called the grapheme-phoneme relationship. They also know all the letters of the alphabet. So when the teacher presents the letter C on a card and says the sound, this information is likely to flow into long-term memory because they already have the schema to be able to connect those things. The goal of the cognitive load theory is to help ensure that students are not cognitively overloaded when learning new biologically secondary information. The load conditions are intrinsic cognitive load, extraneous cognitive load, and germane cognitive load. The amount of intrinsic cognitive load has to do with the amount of element interactivity, and the extraneous cognitive load has to do with the lesson design. Germane cognitive load refers to how much working memory is available to process that intrinsic cognitive load when considering the amount of extraneous cognitive load. So intrinsic and extraneous cognitive load are additive. Therefore, our goal is to limit the amount of extraneous load, manage the amount of intrinsic load, and ensure that the overall germane cognitive load does not overload working memory for our students. By minimizing extraneous cognitive load, managing intrinsic load, by only focusing on one letter that students are already familiar with, this ensures that the students have that germane cognitive load and the lesson does not overload working memory capability of students. In contrast, the cognitive theory of multimedia utilizes the cognitive load theory I just described, but it incorporates the idea of dual channels, or the idea that students have two channels for processing information, a visual and an auditory. Dual channels is only the first assumption made by this theory. The second assumption made by this theory is that there is a limit to the amount of new information that can be processed in each of these two channels at a time. And then there's a third assumption, and that's that students must be actively processing this new information by selecting, by organizing, and by integrating it in order for it to be saved in long-term memory. In our example, students would select the letter C that they view in the visual channel, select the sound C in the auditory or K in the auditory channel. They will then organize this information by creating a mental model and then integrate it into long-term memory. So by focusing only on one sound K, and showing the letter C and the spellings on a card, this is limiting the amount of extraneous processing and managing the essential processing by students, which will ensure that they have sufficient generative processing capabilities and they're likely to store this new information in long-term memory.